All right. All right. We'll go ahead and get this thing started since we are, within 30 seconds of time here, give or take. First of all, thank you all for coming out this afternoon. I appreciate it. Hope you're all having a great Trailhead DX. This is automating the impossible. For the next 30 minutes or so, Jason and I are going to walk you through a little bit about how Salesforce.org scales our CI and our product delivery system to more than 30,000 deployed orgs, 25,000, 30,000 deployed orgs. And really, we operate essentially, the key thing to know is we essentially operate as an ISV inside of Salesforce. And so a lot of the same challenges that you might be having in terms of adapting to the platform or working on the platform is a lot of the same challenges that we had to overcome. So my name's Kevin Bromer. I'm our Vice President of Product Delivery. That just means I get to come up and do the first part of these presentations, and then I get to turn it over to the real geniuses in the room, folks like Jason and other folks on the team. Yeah, good thing to know. Just a reminder, although we're going to be talking about free open source product, if you should decide to make a purchasing decision for some reason, don't. We're just going to give it to you. So be wary of forward-looking statements around that. So to start with a little bit, I want to tell you a little bit just about kind of the kinds of products that we have and what we're actually doing. Salesforce.org basically operates two key verticals for Salesforce.com. We have the nonprofit side and we have the higher education side, or just the general education side. And on the nonprofit side, our key application is called the Nonprofit Success Pack. You may have heard of it before, you may not have. It's pretty ubiquitous in the market. We've got about 15,000 or so production Salesforce orgs that are running this application today, and that number is growing on a daily basis. On the higher education side, we have about several hundred of those. Nonprofit Success Pack is actually a combination of 6 managed packages. The original iteration of the Nonprofit Success Pack was way back in 2007, so we have been carrying this stuff with us for the better part of a decade now. We're one of the early adopters of managed packages, and we got to enjoy all of the, we'll say, joy that comes along with that. Like I said, we have about 20,000 orgs on that. It's also a team of 6 developers. So we're not a huge team, relatively small SWAT team. And in fact, that number doubled only in the last 4 months or so. So historically, we've been a really lightweight team, and we've had to figure out how to scale with the resources that we have in in basically a 1 developer to 10,000 customer kind of scenario. We also have other applications that we support in the nonprofit space as well. Volunteers for Salesforce is a good example of this. We also have what we call our campaign toolkit, which is something that we're working on now and is currently doing some beta testing out there in the market. On the higher education side, we started a little bit later, so we only have 1 managed package. So very much simplifies things for us from a CI perspective. We still have about 1,000 orgs, and we talk about the developer editions, the sandboxes, and the other types of environments that our customers have out there that we are regularly deploying to. Same 6 developers on that side, because we're working on some other products in the higher education space, including Student Advisor Link, which is something that we announced last year at Dreamforce, and we'll be talking a little bit more coming up at this Dreamforce. So I'm going to start with, before we kind of get into the technical weeds, giving you just some key takeaways that I'd love for you to have beyond just sort of the nitty-gritty code. I want to encourage anybody out there, whether you are running a development team, whether you're a member of a development team, whether you're interested in beginning a development team, I cannot emphasize this enough, and I think this is really overlooked. Invest in automation. It pays off in the long run, especially when it comes time to scale. I cannot tell you the number of organizations that I encounter who are great for that those first couple of years, or maybe even 2 years, and then all of a sudden they hit a brick wall. Why? Because the scalability and the automation is not there. There's a lot of business pain, right? You have a limited number of resources. We do not have an infinitely large development team. We need to squeeze the most efficiency out of those developers that we have on staff. We also want our developers to focus on developing. I think anybody who's written any code knows the pain of context switching. And if you're trying to both manage a CI system, manage DevOps, and then also write code into your core system, that's 3 different things you're constantly toggling between as a developer, and that's going to grind on you on a day-to-day basis. We also have rapid release cycles. You need to be aware of this, but we release every 2 weeks. We push a production release to all 25,000 orgs that we have. It's pretty rare out there, and it's been incredibly effective for us from a business perspective and also from a technology perspective. We also, because of that release cycle, we need to make sure that we invest in systems so that there are no surprises at the time of release. If you're going to release every 2 weeks, you cannot, on Friday before release, go, oh man, what is that doing in there? There's just no room for that, right? It's too quick, it has to happen, it has to be cross-checked at development time. We also have to have severe metadata security. If anybody who has ever created a managed package has not accidentally included the, the delivery status field on the opportunity, which is in all those DE orgs, right? We did it. I know a lot of other people have done it. It's easy to let metadata cruft slip into your application just on accident because of the way that, that packaging and the platform works. Cannot let those things slip in accidentally. So there's the business pain that we had to solve for with this, and then there's also the technical pain that we need to address as well. We have new devs, we have new products, we have extensions of those products, and oh, by the way, a lot of our products are open source, so we also take contributions from the broader community into our packages. So how do we accommodate all of that, and how do we do all of that at scale without assigning a developer full-time to be able to handle those things? We also have a complex dependency tree. I talked about the 6 managed packages in the Success Pack. Well, 4 of them are base packages. One's an extension of one of the packages, and then one's an extension of all of them, right? So you're talking about multi-level dependencies that need to be resolved as part of our process. Obviously, we want to take advantage of everything coming as part of a Salesforce DX as well, so we needed to make sure that our system was flexible enough to work and address that. We'll talk a little bit about that. And each project has a different build path. The way that the project is built, because of the dependencies, because of the target audience, because of the application audience, has different needs from an automation perspective. So we couldn't just have one-size-fits-all automation. We had to have per project automation and configurability that we were going to be able to support. And of course, we want to keep everything in the cloud, so we needed to support not just any cloud-hosted CI, but every cloud-hosted CI that we wanted to be able to address. So whether it's something that was home-built and custom-built, like we've used on occasion, or whether you're using Jenkins in an AWS instance, or whatever you're using, we wanted to build something that would be able to utilize whatever your sort of poison of choice was going to be from a CI perspective. So the good news is we've actually done a lot of this work for you already, and we kind of just want to give it to you because we think it's great for the community to be able to leverage this. And also, it accelerates everybody's positive direction when we're all working together on this kind of tooling, right? So we have this rule inside of our organization, and that's my cartoon Mussolini there. The trains must run on time, and what I mean by that is that the release trains must run on time. I talked about our every 2-week releases. Does not matter if there's bugs, does not matter what is happening in the application, that release train goes out, period, end of story. If you miss a release, no big deal, there's another one in 2 weeks, you just get on the next train. We push our sandboxes after QA, and then we push to production the following week. And what that means in practicality is we actually do a push every week, right? One we go to sandboxes, and the following week we go to production. So as I mentioned, there is no holding for incomplete features. There's no holding for bugs. You can only wait for the next train. You merge a fork that's got something, you merge a branch that has something that's breaking to the build in it, guess what? Goes out, we boot it out, the release train goes out on time, and you can fix it up and get it into the next release 2 weeks later. It's incredibly effective, it's incredibly efficient for us to be able to operate in that way, and it guarantees our customers a regular, predictable cadence of release that they know how to adapt to, that they know how to look out for, and that they also know that the product is continuously improving and evolving as part of, in due course of that process. And of course, all of our test environments are going to need to be green before we go out. We test large data volumes. We test at scale. We F-test, so we test in multi-currency environments. We test in different languages. Basically, any environment that our customers encounter, we want to have a replicable test environment to be able to run our code against it and ensure that it works up to par and where we need to be. So real quickly, our process, and then I'm going to turn it over to Jason and kind of kick things from there. From a development side, we maintain isolated development environments. We use some Scratch orgs, some people have some DE orgs that have been hanging around for a while, but we never have multiple developers in the same environment. Every dev maintains their own development environment as is appropriate for them. Every dev's work is run out on an independent feature branch. It ensures that we don't have conflicting merges. It ensures that any merge conflicts that occur at the time to merge to dev can be resolved by the individual developer. And all pull requests are going into master and are reviewed in due course as part of our standard developer ops process. We also have our tested CI pace. So So feature tests on feature to push, that means is that we run our entire test suite as a feature rolls into the application and ensures that what is going to be merged into dev passes builds before it gets through that barrier of being merged directly into dev. We also, every time we merge something into master, we create a beta release of the package. So we recognize that sometimes when you package stuff, it can behave a little bit differently than you anticipate, and there would be an unmanaged code. You have to deal with namespaces. You have to deal with all of those artifacts that come along with that. So every time that we merge a new branch into our master, we generate a beta release out of that, and that beta release is deployed and tested as if it were a production release. It, again, happens automatically, and it ensures that when we go to release to production every 2 weeks, that master is already good to go and green to go because all of the betas that have come with before it are clean and good to go. And then, of course, like I said, we run the beta tests on that beta tag. So it's Browser tests, multi-environment, LDV, performance tests, all of those things. So I talked about the new release every 2 weeks. Before we push out, our QAs essentially go through everything with a fine-tooth comb. They're doing exploratory testing. We run selenium-based browser tests to do smoke testing, and then we do just kind of standard regression testing as part of that. And then finally, push to sandbox on Wednesdays and production that following Tuesdays. Like I said, that rapid release cycle. So that's a little bit about the sort of the what and the why. And then I think for the next part of this, oh, right, and we have to trial force everything and cut that as well because it's a managed package, and we want to make our trial templates available as part of that process. So with that, I'm going to tell you how it's all done. And for that, I'm going to turn it over to our principal release engineer, Mr. Jason Lance.
Hello. So I've been, Kevin hired me almost 4 years ago. It'll be 4 years ago in September. So I've been kind of working at this challenge of trying to figure out how to do CI and release management for our products for about 4 years now. So the biggest part of what we're going to talk about today is cumulus CI. Now, has anybody here used cumulus CI or attempted to use cumulus CI when it was Ant-based? Okay, it's no longer Ant-based. It's all completely rewritten. So that's one thing that I just want to make sure that everybody understands. So you should definitely take a fresh look at it. Cumulus CI now is a tool that automates your interactions with Salesforce orgs, and it automates those as tasks and as flows. It is a single command line interface called CCI. You can do project-specific customization in a single YAML file that you store in the project repository. We'll look more at that in a minute. It also has its own keychain. So kind of like SFDX has a keychain for connecting orgs, there's also an OAuth keychain in Cumulus CI now that you can connect orgs. And you can also create scratch orgs through that. So that's part of the DX integration that's built in. It's been completely rebuilt over the last year, so there's now no Ant in it at all. It's all written in Python. And it's integrated with Salesforce DX, which we'll look at a little bit more. And the other thing is you can wrap your own custom commands. So you can wrap your own command line calls that are kind of pre-configured into Cumulus CI. So it's kind of an orchestration layer that sits on top of Salesforce DX and whatever other kind of build tooling you have. So the core of Cumulus CI is the Cumulus CI YAML file. And this is the file that all the mappings of kind of task names to Python classes that actually do the work is done. All the configuration is stored in this single file. And it's a merged YAML file. So this is kind of a core part or a core concept of Cumulus CI. The original Cumulus CI YAML file comes from Cumulus CI itself. So when you install Cumulus CI, there's the built-in Cumulus CI YAML file. It defines all the default configurations, all the default tasks, all the out-of-the-box flows that we provide. Then, in your local environment, you can create a local global override that will override that YAML file for all your local projects. Then your project's Cumulus CI YAML overrides that global configuration for your project, and you can also have a project local that's outside of version control just in your local environment for overrides. So tasks are the core unit of work in Cumulus CI, and over on the right you can see two task definitions. These are from just the standard Cumulus CI file that comes with Cumulus CI. And task definitions in the YAML file just have a description that's shown in the CLI when people look at task info or the list of tasks. A class path that maps to the actual Python class that's doing the work of the task. We have a bunch of those that are already provided, and each of those task classes can define its own custom options. So you can define those options in the YAML file as well. And then once you have your tasks defined, you map those into flows. And flows are sequences of configured tasks for common build use cases. So the devorg flow, for instance, shown on the right here, is the out-of-the-box flow that comes with Cumulus CI to spin up your devorg. It not only deploys the source directory of your code, but it sets up all the dependencies and all sorts of other things that are really helpful for you. So the flow just has a description and then the list of tasks that are ordered into numbered slots. The reason those are numbered slots is that allows projects to override the individual slot in their YAML file. So the standard out-of-the-box flows that we provide, we have 4 flows for developers that are useful, a number of flows that are useful in the context of CI. And the CI flows pretty much all will run and install, kick off your Apex tests, and kind of record the results. And then we also have flows that are useful to release managers. I included in here the 4 push API tasks that are included in Cumulus CI out of the box. They're not flows, but they're just individual tasks, but they're really handy in the context of release management. So if you want to set up a development org in the NPSP, an example of kind of the general process that you go through, once you have Cumulus CI installed and configured on your system, you would clone our main repository. This is a public open source repository, so you can do this yourself. You run cci org scratch. Dev is the org configuration that you're doing. So Cumulus CI comes with 4 org configurations out of the box: dev, feature, beta, and release that your project can customize. So you just kind of specify the configuration you want, and then scratch here is the name of the org. So we want to refer to this org as our scratch org. The -- default is setting it as the default. So when we run a flow, the devorg flow that we just looked at earlier, it's running against this org by default. So this is the same flow also that contributors to the NPSP can use. So that's all you have to do to set up a devorg. Now, as Kevin mentioned, we have a lot of complex dependencies that we have to manage, and I think this is probably one of the more interesting features of Cumulus CI. So first, we have dependencies on managed packages. So we build extension packages that have to have the right version of the underlying package installed in the org. So you can build a managed package dependency in Cumulus CI that will control all the logic to install, upgrade, downgrade, manage package to a particular version, and that just needs the namespace and the version number that you want it to install. You can do an unmanaged zip, where you basically point it at a URL where it can find a zip file, and it expects to be able to find the package XML kind of in the root of that zip. So it's just unmanaged metadata that it's going to download and deploy for you. And you can optionally reroute that to a subfolder in the zip file, which is if you want to pull down a GitHub repository and deploy some subfolder of that, you can use that functionality. And then the final one, which is the most exciting to me, is a GitHub dependency. So we've actually flipped all of our repositories over to using this now. The GitHub dependency recursively includes all the dependencies from another Cumulus CI project. So it actually, you just point it at the repository, and it inspects the entire repository, looks at its dependencies, and makes those dependencies of the current project. So it's kind of a package manager for Salesforce, I guess. And an example of kind of that dependency parsing. In this basic project Cumulus CI YAML file, I added the GitHub dependency here that points out at NPSP. What that does is it's going to go out and inspect the repository. It's going to find some unmanaged metadata that it needs to deploy. Then it's going to look at the dependencies in the Cumulus CI YAML from that repository. It's going to find these other repositories that it requires, and it's recursive. So one of those repositories requires another. So now we've crawled 6 repositories. And this is the output that the CLI would give you. Is you can see at the top, it's going out and inspecting all of those. And then this is the map of everything that it's going to install in the org. So as far as integrating with Salesforce DX, in the standard, we saw the deploy task earlier on the task slide. So this is the standard deploy task in Cumulus CI, the way it's defined. And what this does is uses Cumulus CI's built-in metadata API client that's written in Python. And a number of our flows, like the devorg flow, use this task in order to actually do the deployment of the main package code. But if in your project you actually want to use force source push from Salesforce DX instead, but still get all the dependency management features of Cumulus CI, then what you do in your project is you just override the deploy task. And the class path here, you can see it's pointing at SFDX org task, which will actually pass the org credentials on to the SFDX command that you're calling. Excuse me. What that will do is that every time somebody runs the deploy task now, it's going to call SFDX force source push instead of using our built-in stuff in Cumulus CI. So you can swap out individual tasks in your project flows incrementally as you want to, and where it makes sense for certain projects, but maybe not for others. And yeah, as I said, it's essentially Salesforce DX with all the dependency management of Cumulus CI built in. So one of the really big goals of when I started thinking about this was really making our automation portable. So when I was first tasked with this, I thought about my automation user is Jenkins. I'm writing scripts. I want Jenkins to be able to run them. As long as Jenkins can run them, I don't care how usable they are. But then our developers also wanted to be able to run them. And really, when you start thinking about it, your non-developers, your QA people, your doc writers, your product managers, your support people, external partners and contributors, your end users, all of these people could use the same automation that you're building for your development. So you want to make that portable. And finally, custom apps might also want to use that that automation too. We'll take a look at that here in a minute. So two quick examples of portable automation that we did in the NPSP project. The first is automating browser tests. So our browser tests are written in Ruby. They're stored in a separate repository. And it's this big kind of nasty command to kick them off and run them, right? So this is what the definition looks like. It's 2 tasks and a flow to automate our browser tests for NPSP. The first task uses the download zip task that's built into Cumulus CI, downloads a zip file into a local folder. The next task actually wraps that command that we were just looking at on the previous slide into a simple task called browser test Firefox, and then the flow maps those 2 in order. So a developer just has to run Cumulus CI flow run devorg, or flow run browser test Firefox in order to kick them off. So the other bit of fun kind of portable automation that we built is test data sort of management system. So originally we had test data that was in a SQLite database, and we wanted to get that into orgs. And so I wrote this kind of mapping system, this task that can take a mapping file in YAML and then also point at a local database and control using the bulk API to do the data load. So it also handles related object data. So you can import contacts and then, or accounts and then import contacts that reference the accounts that you just inserted. And then we also wrote the backwards direction of this a couple of weeks ago, where it'll take the same YAML file and write the SOCL queries to go query the data into a local database for you. And that's portable data that you can deploy into a different org. So the mapping for that looks like this. It's pretty simple. You tell it the Salesforce object and then the local table, the field mappings for the fields. And then you just give it a series of these import tasks. So this next one here is going to import recurring donations. We have fields, which are also pretty standard. You can pass static values into certain fields if you want to set those in the configuration. And then this is how we do lookup. So you actually reference the contacts that were imported before, and it'll go ahead and do the mapping of the Salesforce ID for you. So Kevin mentioned earlier about CloudHosted CI, and this has been, I guess for the last 2 years, something that has really, really weighed on me. It's been a real challenge. So this concurrency dilemma, that most Cloud CI apps are actually built to assume that you're building code inside of their VM. So when you ask them about concurrency, they say, well, sure, we'll just spin up more VMs for you. Problem is, our builds aren't local. They're actually against APIs, and they might be calling against a persistent org. So what I have looked for the last 2 years is a Cloud CI vendor that can that has a feature to allow me to make sure that 2 builds don't run against my packaging org at the same time. And it's not possible with any of the systems that I found. So that's essentially what we wanted. We wanted to queue any builds that are running against a persistent org so that they only run one at a time. We want scratch org builds to run in full parallelization. And ideally, we only want to pay for the build resources when we need it. So we want to be able to spike up and then kind of come back down. So Mr. Belvedere CI is an application that I started building in November of last year. We went live with in January. And it is a very lightweight CI app, specifically built for Salesforce projects and that are configured for Cumulus CI. It runs on Heroku. You can run up to 98 concurrent builds. We've actually tested this with 98 concurrent scratchboard builds. Pretty cool. And it runs Cumulus CI flows for GitHub projects. So it's a very prescriptive system. system. It's not meant to solve every build problem or anything like that. It's integrated with Salesforce DX, so it spins up scratch orgs and deletes them for you. And it also has functionality built in, because it's Salesforce specific, for tracking apex limits on the tests that you run. Cumulus CI generates this data, and it is able to kind of load that in and analyze the data for you. So this is kind of what the build list view looks like. You can see this live now at Mr. Belvedere CI.herokuapp.com. Excuse me. And so on the main build list, this just lists all the builds that run through the system. There's a full text search that you can search all the build logs that have run through. And the builds are just stored in Heroku Postgres. So you have access to all your build data pretty simply. Then when you look at an individual view, you can see here in the log that it's spun up a scratch org and then deleted the scratch org afterwards. When there's a failure, we try to really highlight the failure so that our developers can kind of see, like, hey, here's what went wrong. Also, on an individual build, you can go to the org tab and see the information about the org that this build was run against. If the org's still around, like a scratch org, you can actually log into it through that button, too. And yeah, probably don't have time to cover the architecture to cover this slide. So I'm going to kind of skip over this, but it'll be in the slide deck and available for you. So I talked earlier about the concurrency challenge. And I know there's a lot of Python code on this screen, but just to kind of break it down a little bit. This first chunk here says, if you're running against a scratch org, go ahead and run the build immediately in full concurrency. If you're running against a persistent org, try to get a lock on the org. If you get a lock, run the build immediately. If you don't get a lock, try again in a minute. That's pretty much it. That whole problem that vexed me for like 2 years is that code right there. It's kind of crazy. So the apex limits tracking that I was talking about, Cumulus CI's run test debug task collects the debug logs and then parses them and spits out this JSON file. Mr. Belvedere CI loads in that JSON file from our future builds. And then Mr. Belvedere CI views will highlight those test results. So this is what the report on that looks like. And this view is actually sorted by the worst percent. So which of my Apex tests in the entire suite were the closest to hitting a limit. And you can see the top two here. We're getting a little bit close on those. And so those are things that it provides kind of an early warning system for us on all of that. And so as far as building a Cumulus CI project in Mr. Belvedere CI, it's pretty simple. It's 3 steps. And the steps, just to give you an idea of what it looks like, you have to connect it to the repository, very simple. You have to give it an org configuration, which is basically just pointing it at the scratch org definition file. And then you have to configure the build plan. Build plans are linked to a repo. They're triggered on commit manually or on a tag with a regex of either the branch or the tag name. You specify the Cumulus CI flow that you want it to run, the name of the org that you created, and then the context here is actually the GitHub commit status that it's going to set when that plan runs. So that's pretty much it as far as, I don't know why that was doing that. Yeah, that's pretty much it as far as Mr. Belvedere CI and kind of. So thus far, I think we're getting close to 5,000 builds that we've run through the system since January. So that has definitely helped us with our scaling challenges of adding new developers, of adding new contributors, new products, extension package dependencies, and it really heavily addressed our build concurrency challenges. We used to be limited to build concurrency of 1 for most of our projects, and now we have pretty much unlimited. So that's pretty cool. Yeah, I'll go ahead and kick this off. All right, so just to give you an idea of sort of what this looks like, we're going to go ahead and use Cumulus CI to spin up a new project and at least start the process of getting a devorg going. So in here, I'm using a template that I created using a system called Cookie Cutter. All right, so it gives me prompts to ask me kind of what type of project I want to create. So this time I want to create a managed extension package for NPSP. And just got to give it some basic configuration. And now I've got this repository. and I'll create an initial commit. All right, so now if I do CCI org list, I don't have any orgs, so I'll go ahead and create a scratch org and make it the default, and then kick off the devorg flow. Oh, helps to spell the flow right. Yeah, so when flows run in cumulus CI, scratch orgs get the scratch org configurations in cumulus CI are lazy. So the scratch org doesn't really get created until you actually start to run a build against it. And of course, I failed to create the scratch org. Oh, OK. They started enforcing namespaces, which used to not be enforced before. So let's take that out. Yeah, so that'll create it. Anyhow, while that runs, I guess if there's time for Q&A. Huh? Yeah. OK. Well, so yeah, so if these links up here, they'll be in the slide deck, which will be available as well. But all of the repositories, the documentation for cumulus CI, and all the stuff that you saw, this is definitely a very small sampling of kind of everything that's in it. But hopefully, what gets you interested enough to go take a look at it and maybe get involved. It's also open source, so you can contribute. Thanks.